Hello and welcome. I'm Pravir, and this session is going to be an imaginative inquiry into a quaternary interpretation of quantum dynamics and its technological implications. Now, the structure of this session is the following. I'm going to revisit some quantum fundamentals through imaginative inquiry, transition then to fourfold structure of matter and life. I'll look at further fourfold structure from the bottom up, and this will lead to a discussion of the quaternary interpretation of quantum dynamics and some of its technological implications, and I'll end with a summary and conclusion. So, revisiting quantum fundamentals through imaginative inquiry. When we actually use the power of imagination, we're in good company. We have Niels Bohr, René Descartes, Otto Lowy, Kekule, Ramanujan, among some, who apparently were inspired to use imagination through dreams. I'm not going to go into the details of this, but there's many, many examples of discoveries having started off by using imagination that, in these cases, was spurred by dream. Now, using imagination, I want to ask the following what if questions. So, what if superposition and entanglement in fact work differently than imagined? Now, as per the Copenhagen interpretation of quantum mechanics, you have unknowable infinite possible states that collapse into a single state when measured. And that implies that all complexity of the quantum levels can never truly be known, because the moment you try to measure something or figure out what's happening, it's going to collapse into a measurable state. So whatever you're measuring is going to be determined by your measurement philosophy, by your measurement criteria, by your instrumentation. So if there's something unknown that you don't know what it is, you're not going to get it. What if entanglement never has to be created? So since matter may be already entangled by virtue of arising from a single source, and here one can think about the Big Bang, or one can think about quantum levels, and one can also see examples such as the fact that no two snowflakes are alike, or no two thumbprints are alike. And this implies a fundamental entanglement between all snowflakes and thumbprints, such that they quote unquote know that some other pattern already exists. So, what if superposition is suggesting that there is indeed some order of nature, or rather order to nature? Because the current approach is that when we think about quantum levels, is that it's random and that we have to employ probability and statistics to get a handle on it. But in fact, I could begin to think about superposition as being some kind of function that's superposed on physical form. And this is clear when we think about, for example, the atomic number 47. There's a precise set of functions that show up wherever that atomic configuration exists, which could imply a different interpretation of superposition. Further, there's also this idea that we may be able to influence how quantum objects show up because of a cohesive individual or collective intent. And so that intent then might also act as a quantum metafunction that's superposed upon the mechanics or dynamics of a quantum object. It's important to consider those three situations, or imaginations about superposition, about entanglement, and about randomness, because those three interpretations, the way they're interpreted right now, is the foundation of all quantum computation architectures, regardless of who's pursuing them in today's development of industry. Now, I also want to draw attention to one more type of imagination, and I've written some about this already. It's a double slit dynamics imagination, But there's a particular way in which the double slit experiment is perceived, and that is from the bottom up, in which every photon, it's from the point of view of photon. And the thing about the double slit experiment that I want to draw attention to is that it's really referring to the fact that when you send from a light source individual photons through a double slit, then it still manifests in an interference pattern on a screen behind. And that's counterintuitive because if you send a whole bunch of light simultaneously, you can imagine how that would result in an interference pattern. But the fact that you're sending just single photons through one at a time and it still results in interference is counterintuitive. Now, there's a couple of ways to interpret this. There's the bottom-up way, and in the bottom-up way, if we take it from the point of view of every photon, then we could reach a conclusion that photons somehow share information across time. So there's some kind of superposition function that they all have access to, and then they know precisely where to land in order to ensure that there's a cohesive interference pattern at the back end. And this also implies that all photons, for the length of the experiment, across time boundaries, are entangled in some way. Now, alternatively, I could begin to look at the same experiment from the top down. So if I assume that light is acting as a whole in this experiment, and within light, there's certain properties. So there's a range of what I'd call L properties. And what we could say is that every photon that leaves this light source is already correlated with one or the other of these properties in light. And when it actually shows up on the screen behind, what's every photon is following that correlation, and so is showing up as per its correlation to a certain property that's already been determined from the get-go. And so this kind of interpretation, this top-down interpretation, doesn't require that photons have a knowledge of all other photons and that they're entangled. And as a result of this, I'm not going to go into the details here, but we can see that there's several different branches, if you will, and these imply different trajectories of quantum computational development if, in fact, the behavior is following a top-down approach. Now, today's industry is, in my estimation, following the bottom-up approach. And so there's a certain bias to the way that the technology is developing. So with that in mind, let's begin to look at the fourfold structure of matter and life. So first of all, I want to make the point that nature is a single system. So if we look at quantum particles, they're all sourced from quantum levels. All atoms are sourced from quantum particles. All molecules are sourced from atoms. All molecular plants, which are the basis of living cells, are sourced from molecules. So it's evident that there's a tight integration between one layer of nature and the next. So the question is, why don't we study it as a single system when trying to get insight into one layer or another? So here I'm particularly concerned about the quantum level. If we want to get insight on the quantum level, then we should, as per this logic, be looking at the system as a whole. And that's going to provide us some different kind of insight into the dynamics that might be occurring at the quantum level. And of course, this is leading to my point on the quaternary interpretation of quantum dynamics, which I'm going to get to shortly. And here I'm going to use an example of reverse extrapolation, just building on this logic of nature acting as a single system. Let's first look at the most granular level, that of cells, which we know every cell has 4 molecular plans in it. These molecular plans are called proteins, polysaccharides, nucleic acids, and lipids. However, if we really ask what is the essence of each of these different molecular plans, we could make the case that proteins, for example, in the human cell, there are over 30,000 different proteins. They're spread across the cell. They do all kinds of service. They're present across every function that's happening in the cell. So we could say that there's a correlation between this molecular plant protein and in its lowest common denominator. What it really is, in essence, is this functionality of presence. Similarly, polysaccharides are chains of sugar that provide energy for different cellular functions, and we could say that when we look at the lowest common denominator or the essence of its functionality, we can reduce it to a functionality of power. Nucleic acids, similarly, which we know are instrumental in the creation of DNA and therefore in forming the libraries of cells, is, from this point of view, in its denominated at its lowest functionality in terms of knowledge. And then lipids that create compartments within cells, we can view that as, in essence, being a function of harmony. Now, even when we look at the periodic table, and we know periodic table, all the elements, 108 known elements, are classified into S shell, D shell, P shell, or F shell, and we probe into what really are these at their core, I could make the case that the D shell atoms, for instance, that create all the massive infrastructure around us, in its essence, it's a functionality of presence. The S shell atoms that has elements like hydrogen and helium, which we know power suns and are responsible for or instrumental in nuclear fusion. In their essence, they're a functionality of power. The P shell atoms, I can make the case that since it has elements like carbon and silicon, which are instrumental in creating computing machinery, either animate or inanimate, and that there's different kinds of other archetypes that exist in the P shell, whether metalloids, non-metals, and so on, that there's that spread of archetypes really is providing us a glimpse into the essence of knowledge. And then similarly, the F shell atoms that I can make the case are an experiment in collectivity at the atomic level, because you have the highest atomic number is really displaying this functionality of harmony. But when we go even further or to a low level of granularity and look at quantum particles itself, we know that all quantum particles are can be structured by the standard model, or insight can be gained by the standard model that has four categories in it. You've got the Higgs boson, lepton, quark, and boson. And for example, I know that any quantum particle that has mass has to interact with the Higgs field to the Higgs boson. So Higgs boson is giving us, in its essence, its functionality has to do with presence. Lepton, if we use a surrogate of electron, the release or capture of electrons is always accompanied by a lot of power. And so I can make the case that leptons in its essence is a functionality of power. Quarks determine nucleons and atomic number, and atomic number precisely suggest how an element will behave in the universe. So in essence, it has something to do with knowledge. And then bosons are required for all quantum particles to interact and combine. And so I can make the case that this is, in essence, is a functionality of harmony. So across all these three different levels that really animate life and matter, we have this fourfold functional pattern of presence, power, knowledge, harmony. And the hypothesis is that this, in fact, in these instances, is a fractal pattern of a root pattern that exists at the quantum levels. And there is therefore a dynamic that's happening at the quantum levels that, if we could recognize it, if we could learn to read that, would give us insight into this functionality existing at the quantum level as well. Now, I took a reverse extrapolation point of view from the top down. Now I'm going to look at this same fourfold structure from the bottom up. And here we're going to use imagination again to look at light at different speeds. And I'm going to imagine that there's a light source in the center of a vast volume. This light is traveling infinitely fast. And since it's traveling infinitely fast, it's going to be present everywhere in this volume simultaneously. So it has a property of presence. If there's anything not of the nature of light that arises in this volume, it's going to be overpowered by the nature of light. So this light has a property of power. Since everything that arises and disappears is happening in the fabric of light, therefore light has a quote unquote knowledge of everything that's happening. This light has a property of knowledge. And since everything is implicitly happening in the nature of light, there's also a property of harmony. Now, this is happening in this space where light's traveling infinitely fast. But suppose I were to reduce the speed of light, then the case being made here is that symmetrically, these four aspects of or properties of light would show up regardless of how they're projected, no matter how speed might be different. And the point here is that that's precisely what we just saw when we looked at the top-down reverse extrapolation, where you have these properties, presence, power, knowledge, harmony, that are symmetrically showing up as the very structure of quantum particles, of atoms, of cells, and so on. Now, the way to think about quantum is that it's a mechanism that collects and materializes information and light. So if we take, for example, this original space where light's traveling infinitely fast and it has infinite amount of information in it, and then we take a volume where light's traveling slower, then the point is that quantum is a bridge mechanism that's taking some of this information from this field and parsing it materially into this field where we recognize it differently, but it's still a symmetrical phase of the power of or the properties of light. So delving into that a little more, what we have here is these two layers, if you will, light traveling infinitely fast, and it's got these four properties of presence, power, knowledge, and harmony. And then the point here is that these, when you project this at a slightly slower speed, then there's a differentiation of quantization that occurs so that this idea of presence differentiates into an infinite set of presence, and similarly, power differentiates into a set of power. And so you've got four sets that are infinitely large. And then as you've got a further quantization of light slowing down even further, then seeds are created that are unique combinations of the elements from these four sets. And if we then think about light being projected at 186,000 miles per second, and you've got now all these subtle seeds that exist, and they actually define what space is. So there's a direct correlation between all these different seeds showing up or needing space that defines space. When we think about time, we can think about this essence of what's contained in the seed materializing through a process of time that's relative. When we think about the transformation that occurs, then this invokes the idea of energy. And when we think about the arrangement of seeds to seeds, then this gives the idea of gravity. However, when we look at the essence of space, we know that since it has an archetype of everything that will arise, it has to do with knowledge. Since regardless of any obstacle, the essence of what's in a seed will manifest, has to do with power. Time has to do with power. Since the energy makes something that's subtle into material, it has to do with presence. And gravity is showing us an arrangement between different things, which in essence is the functionality of harmony. Point being that space-time, energy, gravity is also a symmetrical phase of these four properties of light that we're calling knowledge, power, presence, and harmony. So now let's just summarize everything that we've gone over. So we have a light source where we've got light traveling infinitely fast, and in that infinitely fast layer, there's four properties that show up: presence, power, knowledge, harmony. When we quantize or project light slower, it shows up as four infinitely large sets. These sets, when we quantize it further, they show up as unique seeds that have contributions from all the four sets in unique combinations. And then there's a quantum object code that is specified by the idea of space-time, energy, gravity. So when everything shows up at 186,000 miles per second, then we can say that any quantum object, as per this logic that's displayed here, would have a fourfold or a quantum object code associated with it that, in a sense, is its space-time, energy, gravity, quote-unquote, coordinates. We looked at the levels of quantum particles, atoms, and molecular plans, and again saw the symmetrical correlation with presence, power, knowledge, harmony. And without going into it in detail here, but I've looked at in research electromagnetic spectrum and bosons, and again, there's a correlation that can be drawn between presence, power, knowledge, and harmony, and the way that these show up. So we can think about the layer, and if we take the 0th layer as being that layer where the light projects itself at 186,000 miles per second, we take the layers of materialization 1 through 5 from the electromagnetic spectrum to molecular plans. And then we take imaginary layers from these other mathematical spaces that are created through light projecting or existing at a speed greater than c. So this sets us up for quaternary interpretation of quantum dynamics. So the components of this, summarizing, are first, there's quanta, which is the bridge mechanism that parses information from some mathematical space into the space that we know where light travels 186,000 miles per second, where the mathematics is different from the space where light travels infinitely fast. This manifests in a quaternary expression. So there's, as this information is parsed, we begin to see that from the imaginary layers right through all the layers of manifestation, there's a symmetrical phase of light that's showing up. There's a quantum object code related to every quantum object that shows itself. And this has space-time, energy, gravity coordinates. And then since we're talking about a system of layers here, and therefore there is always a feedback and interaction between these layers, this gives us the idea of a persistent quantum computation that's happening at each instant in the cosmos. And these are the components of the quaternary interpretation of quantum dynamics. So now the question is, what are some technological extrapolations of that? So first of all, when quantum particles come together, they create an atom. And one of the first things is that we can begin to leverage the atom differently, because the atom, from this point of view, since it's composed of quantum particles. So in other words, and we know that quantum particles are the basis of any kind of qubit of today's modern day quantum computing equipment. And we know that the electron exists in multiple superposed states. We know that there's entanglement because electrons share the same properties if they have the same atomic number, regardless of where they are. We know that the lifetime of quantum states, that superposition entanglement, endure, so there's stability. And we know that every time that an atom is subject to photons, it's going to change its state. So it's in a state of continual quantum computation. So this implies that you've got an atom that's perhaps the most stable example of a quantum computer, way more stable than anything that we've created. And it's scalable, it creates all molecules, molecular plans, and so on. But however, in the quaternary interpretation, if we see that this is a quantum computer, then we should be able to leverage it differently as well, because now we can use the dynamics or the lenses of quaternary interpretation of quantum dynamics to get other possible operations from the atom that we're not currently pursuing. And so, if the atom is a quantum computer, the question is, what's it computing? And I want to suggest that it's computing code, it's pre-genetic type code, because, for instance, we know that if we have an atom of atomic number silver, it maintains the same functionality regardless of where it is. It's going to be ductile, malleable, superconductive, etc. And this code can be thought of as pre-genetic code that exists for the same purpose as genetic code in cells. And this sets us up for thinking about the intimate correlation between naturally occurring quantum computers and genetic type code, because when we look at molecules that are made from atoms, then also they're continuously computing something. And then when we look at molecular plans that are made from molecules, they're also continually computing code. And then when we look at cells, they're also computing code. And we know that that's genetic code, and that keeps the cell intact, and it gives a lot of intelligence to cells. So this kind of the quaternary interpretation gives us a different insight into a bottom-up access to the code that naturally occurs with all these naturally occurring quantum computers. It also has implications to AI, because if we look at this trajectory of manifestation from atoms to molecules, molecular plants, cells, then it's clear that the intelligence, level of intelligence that's being codified is subsequently more and more in each of these cases. So the implication, if you reverse extrapolate, is that there must be a repository of quantum intelligence natively at the quantum levels. And we also know that, therefore, it's going to provide us some insight into AI compared with QI, because we know that AI is an output of human intelligence. But we know that human intelligence, from this point of view, is an output of QI. So QI has got to be vastly more intelligent than anything that we can create with AI. And so there's basically an implication that if you want to create truly intelligent devices going forward, we're going to have to tap into this quantum level and tap into this thing that we're calling quantum intelligence. So there's considerations in designing QI type quantum computers, and we have to learn to read what's happening at the quantum level. We have to leverage the fourfold dynamics that we have identified here as presence, power, knowledge, harmony. We want to be able to integrate that into or integrate this quantum intelligence into any quantum tech and or computer. And we can imagine that we would require a nano-sized integrated quantum computational intelligence device that then would read and respond to organicness that's happening at the quantum level. And I'd refer to this as IQCI nanocyborg. That has a whole different implication for trajectory of quantum development. Incidentally, I did file a patent for this kind of nanocyborg. Here's some of the gate structure and some of the different math that would animate it. And when we look at the possibilities of nanocyborgs, as I mentioned, there's revolutionary access to a generation of materials and change the foundations of material science, because we're looking at materials from the bottom up, where also we have revolutionary access to management and maintenance of life, again, because we're looking at molecular plants and cells from the bottom up. And we're also looking at facilitating the emergence of other forms of intelligence that may be derivative from quantum intelligence. And if we look at some further possibilities, then we could say that the use of IQCI nanocyborgs gives access to fourfold patterns. And at the root of these fourfold patterns, we could say that there's a quantum level space-time energy gravity pattern that, if we could harness it, would give revolution in a couple of areas. First of all, it could potentially provide us with an inexhaustible source of energy. And second, it could, beyond its terrestrial use, be leveraged for extended space travel. And also, I want to suggest that the IQCI nanocyborgs, because they would allow deeper interaction with quantum properties beyond those known properties of superposition, entanglement, tunneling, and annealing, such as a couple that I've pointed out here, like quantum intelligence and fourfoldness. The IQCI nanocyborg could potentially co-create in partnership with the underlying quantum intelligence, and it could leverage the patterns and manipulate these to create technologies that we can't even imagine right now. So summary of key points. We started with the importance of imagination, looked at different fundamentals for quantum dynamics, considered the double slit experiment deeply, looked at nature as a single system. We looked at the fourfold structure of matter and life, the structure from the bottom up of light. That gives us insight into what might be happening at the quantum level. We propose a quaternary interpretation of quantum dynamics, where quanta is a bridge mechanism, where there's fourfold expression that originates in these imaginary layers. There's space-time energy gravity code that surrounds every quantum object. And there's a persistent computation leading to refinements and emergence of new form. Technological possibilities. We can leverage atoms, molecules, molecular plants, and cells differently than we do. We have bottom-up access to genetic type code. We now can play with something called quantum intelligence. We can create QI type quantum computer. And that's with the advent of nanocyborgs, we now have a completely different way to deal with material sciences, maintenance of life, quantum intelligence, and possibly inexhaustible energy source, space travel, quantum feedback mechanisms, and quantum patterns. Thank you.